So in today's lesson, I'm going to be talking about complex numbers and imaginary numbers. All right, so to start out, so far in equations that we've had, we've only dealt with what's called real value solutions. So I want to show some examples of these real value solutions before we introduce these complex or imaginary numbers. So I'm going to show some examples of real value solutions. Okay, so for the first example, we have x squared equals 4. Well, we know that this has two solutions. It has the solution x equals positive 2 and x equals negative 2, which we also often write as x equals plus or minus 2. Okay, and then let's do another example. So another example is x squared plus x minus 6. Well, we can factor this into x plus 3 and x minus 2. And we can check our factoring by expanding this. And so then we know that our two solutions to this, which are real value solutions, are x equals negative 3 and x equals 2. So those are two examples of ones that have real value solutions. And then lastly, I'm going to do another example with a real valued solution involving the quadratic formula. So we'll review that. So what do we do if we're given an equation that we can't factor and we don't know how to solve it? Well, we can use what's called the quadratic formula. And so just to remind you, this is a little bit of review. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac. All of that over 2a. Okay, so one example using the quadratic formula is, we're going to call this example 3, and it's x squared minus x minus 3. Okay, so we can't easily factor this, and so we're going to use the quadratic formula. And so negative b is going to be negative negative 1, which is 1, plus or minus the square root of negative 1 squared, which is 1, minus 4 times 1 times negative 3, all over 2 times a, which is 1. All right, and this simplifies to be 1 plus or minus the square root of 13 over 2. And so those are the two real valued solutions for this equation using the quadratic formula. So what happens whenever our solutions are not real values? Well, that is what I'm going to show you next. What happens if you're given x squared equals negative 1? So if we were going to try to solve this, we would take the square root of both sides. And that would give us x equals square root of negative 1. Well, we don't want to take the square root of a negative because that would not give us a real value. So in order to remedy this, mathematicians define a new number called I, and this is called I equals the square root of negative 1. And therefore, I squared equals negative 1. So in this situation, our answer would be x equals I. The square root of any negative real number can be expressed as an imaginary number in terms of I. First, I just want to show you kind of a general guideline for problems like this. Let's say you have, if b is a positive real number, and the square root of negative b equals I square roots of b. And you can also write it as square root of b times I, but you have to be careful with notation like this, that you do not put the I underneath the radicals. So I think it might be better to write it like this if you do have a radical in there. Okay, so let's start out with the square root of negative 81. So we know that the square root of 81 is 9, and we know that now that since there's a negative under the radical that we're going to need to involve I. And so I will show you how to kind of think about this as you're doing it. So I'm going to break this up into square root of -1 times the square root of 81. And this is equal to 9, and the square root of -1 is I. And so the answer is going to be 9I. And you can check yourself whenever you're doing problems like this, especially at the beginning when you're first learning it, by squaring this to see if you get what's inside of the radical here. Okay, so we're going to take 9I squared. Well, remember, I squared is -1, and so this is like saying 9 squared times I squared. Okay, so we have 81 times I squared, which is -1, and so we get -81. And that matches what we have inside of the radical here. And so when you're first learning these, you can check over your work so you make sure that you're thinking of it correctly. And so let's do another example. Okay, so what if we have I'm gonna put second example here, square root of -11. Well, this is like saying square root of 11 times square root of -1. Well, square root of 11 does not simplify anymore because it's a prime number, and so we can just do it as I times square root of 11. Or if you wanted to, you could do square root of 11I, but you have to be really sure that the I is outside of the radical, so I prefer this notation. Okay, and another example, let's call this example 3, would be the square root of -60. So that is how you break down 60. Well, this right here, since we have matching ones of these, we can put these outside of the radical, and since we have a negative inside of here, we need to put 2I square roots of, since these are both prime, 15. And that is how you would work a problem like this, where it's not a perfect square. You would first make the little factor tree and then write it out like this. Okay, so next I want to talk about a little bit of theory behind this. So we have here square root of A times square root of B equals the square root of A times B. If these two, square root of A and square root of B, are real roots. And then square root of A over square root of B equals the square root of A over B, if a square root of A and square root of B are real roots. And so let's see this kind of in practice with some examples. Okay, so for my first example, I put example 1, square root of -10 times square root of -25. So since these do not have real roots because there is a negative under the radical, it will not be equal to the square root of -10 times -25. So we need to work this out using our new imaginary number called I. So the square root of -10 is the same thing as saying I square roots of 10. We can check, again, like I said earlier, by squaring this, and so I squared is -1, and then square root of 10 squared is 10, and then that matches up with what's inside of our radical here. And then this right here times 25, that is the same thing as 5I. And so we have here 5 square roots of 10, and then what do we do about this I times I? Well, I squared is -1, so we're going to tack this onto the front as in -1 times that. And so the final answer is going to be -5 square roots of 10. Right, so for my next example, I'm going to do square root of -16 times square root of -25. Okay, and so square root of -16 is 4I times square root of -25 is 5I. And so first we're going to multiply these two together, the 4 and the 5, so 20, and then we're going to multiply the i's together. I squared is -1, so the answer is -20. Okay, so for my next example, I'm going to do square root of -30 times square root of -10. So I'm going to break down -30 into 3 times 10. So we have these two to match up here. And since we have two of these, we can put these outside of the radical. and then this will be inside of the radical. And since both of these would have a negative inside of the radical, they will go to the outside, and we would have I times I, and so that would be I squared, and so we would have negative 1 times 10 square roots of 3 as our final answer for this one. So lastly, I just want to touch on some examples involving the quadratic equation. And so for my first example, I'm going to have x squared plus 4x plus 5 equals 0. Okay, and if you remember from earlier, the quadratic equation, I'll write it over here, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so for this one, we'll have negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times 5, which is c, all over 2 times 1. And so we'll have negative 4 plus or minus the square root of 16 minus 20 is negative 4 all over 2. Square root of negative 4, maybe I'll put a little equals and a little equals so we don't get our steps mixed up. So the square root of negative 4 is going to be 2i. And so lastly, we can take a 2 out of all of our terms here, so we'll have negative 2 plus or minus I. One more example involving the quadratic formula is we can do x squared minus 6x plus 25. Okay, so we want to take our equation here and use the quadratic equation to solve it. So negative b is just going to be negative 6, which is 6, plus or minus the square root of 36 minus 4 times a, which is 1, times 25, which is c, all over 2 times 1. Okay, and so we have 6 plus or minus the square root of negative 64 over 2. And so we can put 6 plus or minus, the square root of negative 64 is 8i over 2. And then lastly, we can take a 2 out of everything again, and so we will have 3 plus or minus 4i as our final answer for this one. Just to kind of sum up my points, first we had worked with equations that have real value solutions, and now that we know about the imaginary number called I, we are able to expand our skills and solve equations that have roots that are not real. And so my partners will do some more examples and explain further. Thank you so much for listening.